Hello everyone, this is Zhang Fengzhang, and I'm going to do the homework for the two and second question, for the one and the second question. Okay, for the first question, we have seen that we need to find out what is the fyy and the density function fyy in terms of the density function fxx and the distribution function fxx. Okay, what we have known is that we have known what is gx. Gx is like this when x is like this one. Okay, and we can draw a picture for gx. It is like this, and it is easy to find out that when x is in -0, then y is only 1, and for x is more than 0, then y is changed like this. So we can write like this: gx x minus 0, 1, and 0 for middle of the 0 and 1, and minus x plus 1 in x when x is from 1 to 2. When x is more than 2, then y is minus 1. Okay. Now, the problem of this question is to figure out the motivation from the fxx to the fyy. And as we assume that if fxx, the density function of x, is like this, I just draw it randomly, and then we assume that the distribution function of x is drawing like this. So we're gonna find the different y. Okay, the first thing we should do is to use the definition of the distribution function of y to figure out what is the relationship between y and x. And we can know that the distribution function of y, fyy, is equal to probability of y smaller than y. And this kind of y we could use is by different ways. Okay, this is the following thing we need to figure out is that for different x, and we have got different y, and we're gonna put y in terms of x. So the first thing is that when y is equals to 1, then x is minus 0. So we have that the probability of y equals to 1 is the probability of x smaller than 0. So it is very easy to find out that when this kind of thing happens, this is equals to the distribution function of x when x equals to 0. Is that right? Okay, and the second thing is that when y is 0, then the probability of y is 0 is from, okay, we can see that it's like this, it's in this region. So x is in the 0 and 1. So, and this equals to the distribution function of x from 1 minus 0. And third thing is that we're gonna find when y equals to minus 1, then x equals to more than 2. So this one equals to 1 minus distribution function of x of 2. And the last thing is that when y is equal to minus x plus 1, and then we put this equation to y. So fyy equals to probability of y minus than y. So we can change this y into like by using this equation. So we have probability of minus x plus 1 is smaller than y. So we're gonna put x in terms of y. So we have this equals to the probability of x more than 1 minus y. So this thing is happening like this equals to 1 minus distribution function of x when x equals to 1 minus y. Okay, and if we have these four equations, we're gonna use by using fxx by us very easily moving of fxx, we can get fyy. Okay, we see that when y equals to 1, then the distribution function of y equals to distribution function of x when x equals to 0. Okay, we see that when x equals to 0, we can assume that this point is the fx0. So we put it here. When x equals to 1, then then distribution function of y is equals to fx0 like this. Okay, and when y equals to 0, then it's equals like this. And similarly, we put these 2 points. This is x. This point when x equals to 1, x equals to 0. We put the minus of this equation. So when y is equals to 0, so we got the f(y) equals to fx1 minus fy0. Okay, and we probably see that in the third equation is similar. So we put it here. Put it here. And this point is 1 minus fx2. And the last equation is a kind of moving function. We just use the shifting of fxx to fyy. We can see that fyy equals to 1 minus fx 1 minus y. So it is kind of that we first find out what is the